Alright, so in this problem, I have 9 to the power of 900 minus 9 to the power of 902. So to solve this, I'm going to first go ahead and rewrite 902 as 900 plus 2. So now I have 9 to the power of 900 minus 9 to the power of 900 plus 2. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, 9 to the power of 900 plus 2, that's going to equal 9 to the power of 900 times 9 to the power of 2. Now from here, if I factor out 9 to the power of 9 to the power of 900, I get 9 to the power of 900 times 1 minus 9 to the power of 2. Now 9 to the power of 2, that's simply equal to 81. So now I have 9 to the power of 900 times 1 minus 81. And 1 minus 81, that's equal to negative 80. So I have 9 to the power of 100 times negative 80. Now 9, that's the same thing as 3 to the power of 2. So now I have 3 to the power of 2 to the power of 900 times negative 80. And this is the same thing as 3 to the power of 1800 times negative 80. So I can actually move this negative sign to the front. So this is actually going to equal negative 3 to the power of 1800 times 80. So this is my answer. Now, a second method of solving this problem. First start with 9 to the power of 900 minus 9 to the power of 902. Now, instead of rewriting 902 as 900 plus 2, I'm going to rewrite 900 as 902 minus 2. So now I have 9 to the power of 902 minus 2 minus 9 to the power of 902. Now I'm going to rewrite this as 9 to the power of 902 plus negative 2 minus 9 to the power of 902. So now this is equal to 9 to the power of 902 times 9 to the power of negative 2 minus 9 to the power of 902. Now if I factor out 9 to the power of 902, I get 9 to the power of 902 times 9 to the power of negative 2 minus 1. Now this is the same thing as 9 to the power of 902 times 9 to the power of negative 2 is the same thing as 1 over 81. So I have 1 over 81 minus 1. And this is the same thing as negative 80 over 81. So this is my answer. This is another way of writing the answer. Alright, so for this problem, I have x to the power of x to the power of 4 is equal to 64. So now to solve this problem, I'm going to first start by taking the power of 4 on both sides. So now I have x to the power of x to the power of 4 to the power of 4 is equal to 64 to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And m and n, I can actually change the place of these two. So this is the same thing as a to the power of n times n. Now, if a to the power of m times n is equal to a to the power of m to the power of n, this means that a to the power of n times m is going to equal a to the power of n to the power of m. So we have x to the power of x to the power of 4 to the power of 4. And we can think of x to the power of 4 as m and 4 as n. So if I switch these two places, I get x to the power of 4 to the power of x to the power of 4 is equal to 64 to the power of 4. Now 64, this is the same thing as 8 to the power of 2. So now I have x to the power of 4 to the power of x to the power of 4 is equal to 8 to the power of 2 to the power of 4. Now remember, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 8 to the power of 2 to the power of 4, that's going to equal 8 to the power of 2 times 4, which is 8 to the power of 8. So now I have x to the power of 4 to the power of x to the power of 4 is equal to 8 to the power of 8. Now I'm going to let the variable y equal x to the power of 4. So now if I replace x to the power of 4 with y, I get y to the power of y is equal to 8 to the power of 8. Now, if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b as long as b is greater than or equal to 1. So in this case, I have y to the power of y equals 8 to the power of 8, and as you can see, a is greater than or equal to 1, meaning this I could write this in form a equals 8 or y equals 8. So remember how we set y equal x to the power of 4, meaning I have x to the power of 4 is equal to 8. So now to solve this, I'm going to take the fourth root on both sides. So now I have the fourth root of x to the power of 4 is equal to fourth root of 8. Fourth root of x to the power of 4 is simply x, so I have x is equal to fourth root of 8. So this is my answer. Alright, so in this problem, I have 2 to the power of 20 minus 1. So to solve this, I'm going to first start by rewriting 2 to the power of 20 as 2 to the power of 10 times 2. So now I have 2 to the power of 10 times 2 minus 1. Now, if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So 2 to the power of 10 times 2, I can rewrite as 2 to the power of 10 to the power of 2. Now I have this minus 1. Now 1, that's the same thing as 1 squared. So now I have 2 to the power of 10 to the power of 2 minus 1 to the power of 2. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is equal to 2 to the power of 10, and b is equal to 1. So now I have 2 to the power of 10 plus 1 times 2 to the power of 10 minus 1. So if you guys already didn't know, 2 to the power of 10, that's equal to 1024. So now I have 1024 plus 1 times 1024 minus 1. 1024 plus 1 is 1025. 1024 minus 1 is 1023. Now I'm going to write this as 1000 plus 25 times 1000 plus 23. Now to solve this, I'm going to distribute 1000 first. So now I have 1000 times 1000, which is 1000 squared, plus 1000 times 23, and I have this, plus now I'm going to distribute 25, 25 times 1000, finally plus 25 times 23. Now let's go ahead and simplify this. 1000 squared, that's the same thing as 1 million, plus 1000 times 23, that's 23,000, plus 1000 times 25, that's 25,000, plus 25 times 23, you can do that right here, 25 times 23, 5 times 3 is 15, 3 times 2 is 6, 6 plus 1 is 7, 2 times 5 is 10, carry the 1, 2 times 2 is 4, 4 plus 1 is 5. So if I add these, I get 575. So I have 1 million plus 23,000 plus 25,000, which is 48,000, plus 575, which is 48,575. So if I add these two, I get 1,048,575. So this is my answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this problem without a calculator. So we have 6 to the power of 6 plus 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 6 to the power of 6. Now, because all of these terms are the same, I'm actually just going to factor out 6 to the power of 6. So if I factor out 6 to the power of 6, I get 6 to the power of 6 times, now 6 to the power of 6 divided by 6 to the power of 6 is 1 plus, same thing, 1 plus, same thing once again, 1 plus 1 plus 1, finally plus 1. So now we have 6 to the power of 6 times 1 plus 1 plus 1 plus 1 plus 1 plus 1. Now let's simplify what's in the parentheses. The sum of all these ones is 6. So now we have 6 to the power of 6 times 6. And whenever we're multiplying exponents, let's say we have a to the power of m times a to the power of n. All we do is we simply keep the base the same and we add the exponents. So this would be a to the power of n plus n. Now for 6 to the power of 6 times 6, well 6 is the same thing as 6 to the power of 1. So this is going to be 6, because we keep the base the same, to the power of 6 plus 1. And 6 plus 1 is 7, so this is equal to 6 to the power of 7. Now, an easier way to do it is, instead of factoring out 6 to the power of 6 in the beginning, well, you can already see that there are 6 to the power of 6's, right? So that would just be 6 to the power of 6 times 6. And then 6 to the power of 6 times 6 to the power of 1, well, we already did this. This would be 6 to the power of 7. So that's just a faster way of doing it instead of factoring it and doing all of that.